Hello Unites and welcome back to Math and Magic. In this lesson we're continuing with our topic of linear relationships and we're going to be talking about solving simultaneous equations graphically. So in this lesson we want to be able to, by the end of this lesson, explain how to solve simultaneous equations with a graph and find points of intersection of two lines. Now let's just do a quick summary of what we've actually done in this topic and also in earlier topics. So if you remember from earlier this year, in the topic of algebra, you looked at solving simultaneous equations. Now, what are simultaneous equations? Now, simultaneous equations is when you've got two equations or more. So here, for example, x plus y is equal to 2, and x minus y is equal to, let's say, 1. Or actually, let's pick a better number. 2. Here, you have two equations, and when you solve it, you actually get a pair of solutions. You get x is equal to a number and y is equal to a number. And this makes up your solution to your simultaneous equation. So these, as a pair, make up your solutions to a simultaneous equation. And the way that you solved it was, well, actually you looked at two different ways of doing this. So you talked about, first of all, the substitution method, or you did the elimination method. And so here, with your substitution method, you rewrote one of the equations to have, for example, x be the subject, and then you replaced x in the other equation with your whatever you had on this side. The elimination method was you either added or subtracted your two equations, and then you got rid of one of your pronumerals, and you solved from the other one, and you subbed it back in. So that's how you solved simultaneous equations from earlier this year. And it gave you this pair of solutions. So x is equal to a number, and y is equal to a number. Now, there's actually a third way that you can solve a simultaneous equation, and that's what we're going to be looking at in this section here. That's if you do it graphically. And what this looks like is, well, this equation you can actually draw on a Cartesian plane. This whole topic we've looked at drawing equations on Cartesian planes, linear relationships on a Cartesian plane. And we've got the skills of doing that. We've gone through how to plot a table of values to get points to draw on a Cartesian plane. We've gone through how to find the intercepts to sketch a line like that. We've gone through using the gradient intercept form to sketch, find the y-intercept and use the gradient to find the second point. And we've done all three of these methods to help us find to draw a linear relationship on a Cartesian plane. What we can do is we can actually draw these two linear relationships on a Cartesian plane, and that will get me the solutions. X is equal to a number and y is equal to a number. But when we do this with a Cartesian plane, well, when you think of x is equal to a number and y is equal to a number, that's a little bit like a coordinate. When you have a coordinate, you've got an x value and a y value. So our solutions for when we draw graphically is going to be a coordinate, a point where two lines touch. And that's what we're going to use here when we're solving simultaneous equations graphically. So let's have a look at the definition here. When we plot equations from simultaneous equations on a Cartesian plane, the solution is the point of intersection. Now, point of intersection just means the coordinate where these 2 points touch on the Cartesian plane. That's what we're looking for in these questions. So what we're going to do in this lesson, first we're going to see if a point of intersection lies on a line. And it's a bit of a recap of something that we looked at earlier in this topic. And actually we're going to go through how we solve simultaneous equations using the graphing method. So let's have a go at this. The first part, checking a point of intersection. Now, earlier in this topic, we looked at determining if a point is on a line. So the way we determine if a point is on a line is we substitute the x coordinate, and this is usually the right-hand side, and then we compared that with the y coordinate. So we sub in our y value and we put usually the left-hand side of our equation. And if they matched up, that meant that that point was on our line. If it's determining if a point of intersection is on a line, we just need to check that a point of intersection, so a coordinate, is on both of our lines. If it's on both of our lines, that means that our two lines touch at that point. So, to decide if the given point at the intersection of the two lines is at the intersection of the two lines with the given equations. So let's have a look at these examples. First one, A. We've got these two equations here. Y is equal to 2x plus 3 and y is equal to negative x. And we want to check that if the point negative 1, 1 is going to be on this line. So negative 1, 1. Let's have a go at this. So what I'm going to do is I'm going to substitute this point negative 1, 1 into both of these equations and see if they are both on the, this point is on both of the lines. And if it is, it's at the point of intersection. So let's do that with the first one. So y is equal to 2x plus 3. Now if you have a look at my coordinate that I'm substituting, we've got -1, that is my x value. And I've got 1, which is my y value. So what I'm going to do is I'm going to replace x with -1 and y with 1. So I'm going to start off, I'm going to do my left-hand side. So my left-hand side, if you notice for this equation, I've just got y. So I've got y. I'm going to substitute y is equal to 1, which is what this value tells me. So that just gives me 1. Okay, so that's my left-hand side. I'm now going to do the same thing with my right-hand side, but instead of replacing x with 1, I'm going to replace it with -1. So that's what I'm going to do here. I'm going to write the right-hand side. So on my right-hand side, I've got 2x plus 3. I'm just going to replace x with 1. So I've got 2 times 1 plus 3. So here, oh, hang on. It's 2 times -1 plus 3. So 2 times -1 gives me -2 plus 3. -2 plus 3 gives me 1. And so here, -1, 1 is on, -1, 1 is on y is equal to 2x plus 3. The reason being is because both the left-hand side and the right-hand side match up. That's good for us. Let's check the other equation. So here, I'm just going to check it for the other equation. So the other equation, I'm going to draw galaxy lines to break it up. The other one is y is equal to -x. We're going to do this exact same step. So left-hand side, we're replacing y with 1. So here we've got left-hand side is equal to 1. Now on my right-hand side, I have -x, and I'm just going to substitute -1 into this. So here, when I substitute -1, I get -1. -1 will just give me 1. And if you notice, both of these also have the same value. So therefore, -1, 1 is on the line y is equal to -x. And so if -1, 1 is on the y is equal to 2x plus 3, and also on y is equal to -x, that means that therefore -1, 1 is the point of intersection. There we go. So here, when we're checking if a point is a point of intersection or if it lies on both of the lines, we just substitute that point onto both of those lines. This is similar to what we did quite a few lessons ago early in this topic. I'll try and find the link to that and post it in the comments. But that's what we're doing in this first part. Okay, let's have a look at another example of this. So here, let me just move this across so I've got a bit more space. We've got two equations. Well, once again, y is equal to -2x and 3x plus 2y is equal to 4. And we want to check if this point at 2, -4 is on both of those lines. Is that point of intersection? So let's check that. Let's start off with y is equal to -2x. So let's just check my point. My point has an x coordinate of 2 and a y coordinate of -4. So I'm going to do my substitutions here. So I'm going to do it on my left-hand side. So left-hand side of my equation, I just have y. And so I'm just going to replace, I'm going to write y. I'm going to replace y with -4. So here I've got -4. Okay, good. My right-hand side is -2x. So here that's the -2x here. I'm going to replace x with 2. So here this becomes -2 times 2. -2 times 2 will give me -4. And here we've got the same value on both sides. So therefore 2 -4 is on y is equal to -2x. Great, that's my first line done. Now that I've done that, I also need to do that with my second line. My second line has the equation 3x plus 2y is equal to 4. Okay, here notice everything is on my left-hand side, so I'm just going to deal with my left-hand side first. So I've got 3x plus 2y. I'm just going to replace x with 2, y with -4. So here I'm going to have 3 times 2 plus 2 times -4. 3 times 2 will give me 6, plus 2 times -4 will give me -8. 6 plus -8 will give me -2. Now, if you have a look on the right-hand side of this equation, well, on my left-hand side, I had this guy here. On my right-hand side, I had 4. Now, my right-hand side is equal to 4. Notice here, these two don't match up. So that means 2 -4 is not on 3x plus 2y is equal to 4. That's not great. So what that means is Therefore, 2, negative 4 is not the point of intersection. So here, if we want to check if something is a point of intersection, it needs to be on both of those lines. Similar to like when we solved simultaneous equations earlier this year, in order for a simultaneous equation to be a solution, it needs to both satisfy the first equation and also the second equation. Here, the point needs to satisfy our first line and our second line as well. It needs to satisfy both lines. So if the point doesn't lie on both of the lines, it means it's not a point of intersection. It's not our solution. So that's how we check if a point of intersection is on a line. We substitute that point into both of the equations in our question. If it lies on both of those lines, that means it is our point of intersection and we're good. If it doesn't lie on both of the lines, then it's not good. It is not our point of intersection. Okay, that's the first part of today's lesson. The second part, we want to actually solve graphically. So this is just a way of checking whether or not our answer is correct. The second part is we want to actually solve our our simultaneous equations graphically. So here, these are the steps we're going to follow. Solving simultaneous equations graphically. The steps are, first step, sketch the two equations accurately on the Cartesian plane. An important note here is to do it accurately. You want to make sure that you are as accurate as possible because you are going to be reading off the coordinate of the point of intersection. If you don't draw your graph to scale, if your lines aren't straight and it's all wobbly, that means that you're not going to be able to accurately read off that coordinate. So here, we want to draw our two equations accurately on a Cartesian plane. My additional note here, it doesn't matter which method you use. You could create a table of values. You could find the intercepts. You could use the gradient intercept form. You can use any method that you want. As long as you can graph it accurately and correctly on your Cartesian plane, that's all that matters. These are 3 different skills that we've used over this topic, and you can use any one of them to help you graph it. So that's the first step. Graph or sketch your two equations accurately on the Cartesian plane. First step. Second step is then you want to locate the point of intersection. An important thing to note here is, well, my point of intersection has an x coordinate and a y coordinate. So our point of intersection, we just want to write down what our point of intersection is. It has an x coordinate and a y coordinate. And the final part is then to write our point of intersection as a solution. So what we want to do at the end is just go, okay, my x coordinate was this number, my y coordinate was this number. And so we write we would write x is equal to our number and y is equal to a number. That's what we're going to do as the final step. So let's have a go at applying this on our Cartesian plane. So here, let's have a go at this one here. Solve for the simultaneous equations y is equal to 2x minus 2 and x plus y is equal to 4 graphically. Okay, so let's do this using this step. The first step that we're going to do is sketch the two equations accurately on my Cartesian plane. So let me just set this up. So let's sketch this first one. Y is equal to 2x minus 2. Now I'm going to sketch this using the gradient intercept form because this is already written for me in the gradient intercept form, which is quite lovely. So here, m is equal to 2. That's my gradient. And my y-intercept is negative 2. So if I was to sketch this on my Cartesian plane, I'm going to grab out my shapes. I'm going to draw out my Cartesian plane. I'm going to make it a little bit bigger so I can actually sketch this accurately. So my Cartesian plane, x, y, I want to make the scale accurate. So 1, 2, 3, 4. 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. Negative 1, negative 2, negative 3, negative 4. Okay, so my first one, I have a y-intercept of negative 2. So I first put down the point at negative 2 on my y-intercept, and it has a gradient of 2. So that means that every time it goes across by 1 to the right, it goes up by 2. So I'm going to put a second dot here, across by 1, up by 2. So that's my second point. And so here I can draw a line through it that looks like this. So I've sketched, oh, hang on, let me just zoom out a bit so I can sketch this a little bit more accurately. Should I go there? Okay, like that maybe. Okay, cool. Like this. Okay. I think I sketched it okay. Actually, it's a little bit off, I think, now that I look at it. Now, someone said in the comments, so the lines don't need to be as accurate as you think. Unfortunately for this one, the lines do need to be fairly accurate so that we can read off the point of intersection well. And unfortunately, I don't think my... it's like about there. Okay. Oh, I guess I'm going to have to make do with this. And we'll hope for the best for the rest of them. If you have a ruler, this will be help you quite a bit. Unfortunately, my ruler doesn't let that angle in between, which is annoying. Okay, so I've got my first line. This is y is equal to 2x minus 2. Okay, now the next one is, the second graph is x plus y is equal to 4. So I'm going to do x plus y is equal to 4. I'm going to do some working out here. I'm going to draw this using the intercept method, because here, notice here, I've got x and y on one side. It's easy to just sub in 0 for both of them and just figure out what the intercepts are. Now, the intercepts, the x-intercept is when y is equal to 0. So if y is equal to 0, I have x is equal to 4. So I'm going to put a dot and x is equal to 4 over here. The second one, the y-intercept, is when x is equal to 0. So y is equal to 4. And so here, I'm going to put a dot up here. So I've got those two. I'm just going to draw a line through those. And notice here, so this is where my drawing is actually a little bit off. And so there, that is where this line would be. So this is x plus y is equal to 4. Okay, now what we want to do after we've drawn this, so we've drawn it accurately. I've tried to draw it as accurately as I can, but my computer doesn't actually, my ruler doesn't let me do those accurate measurements. Now if you have a look, it has this point of intersection over here. Now I've drawn it a little bit bigger because I know where the solution should be. But if you have a look, we're just going to read off the coordinates. Now if you have a look at this point of intersection, we have to have an x coordinate, so point of intersection. I'm just going to shorthand it to POI. Here it has an x value of 2, so it's going to be 2, 2. If you have a look, that has an x coordinate of 2, a y coordinate of 2. So my point of intersection is at 2, 2. And so therefore, my solution is x is equal to 2, y is equal to 2. And that's just my final step there. Okay. So here, what we did was we graphed our two lines really accurately. So I drew the first line using the gradient intercept form, and I drew the second line using the intercept method. If you're not sure how to do this, have a look at earlier videos in this topic, and those will hopefully help you out in how to do these particular steps. Then once we did that, we read off the point of intersection. So the point of intersection was over here, and I read down and I read across. And so my point of intersection for this one was 2, 2. It had an x coordinate of 2 and a y coordinate of 2 as well. Then from there, we just write down the solution. Here, x is equal to 2, y is equal to 2. And that's all we need to do as a final step. Now, there's a few ways that we can check this. One of the ways is you could solve this graphically, solve this using simultaneous equations that you did earlier last year, just to check, earlier last term, to check that your solutions are correct. That's one of the ways you can do this. We can also substitute this point back into the equation. So for example, if I was to sub in 2, 2 into both of the lines, so y is equal to 2x minus 2, let's sub that point in. So if I substituted 2, 2 on my left-hand side, I'll get y, which is 2. And on my right-hand side, I'm substituting 2 into x. So here, this is 2 times 2 minus 2, 4 minus 2, which is 2. So that works for my first line. And let's do that for my second line, x plus y is equal to 4. I'm going to substitute 2, 2, left-hand side. So if I substitute 2, 2 into this, I got x plus y, which is 2 plus 2, which gives you 4. And my right-hand side also gives you 4. And so here, these two in my first equation match up. So it's good for my first equation. Here for my second equation, these two match up as well. So they're good as well. Okay. So that's how we actually solve an equation, simultaneous equations graphically on our Cartesian plane. So let's go through over the steps that we did today. So what we did today. Today we talked about how we can solve simultaneous equations graphically on a Cartesian plane. When we're solving simultaneous equations graphically on a Cartesian plane, our solutions are the points of intersection. So we want to read off the x-coordinate and the y-coordinate of our points of intersection. We firstly checked if a point of intersection was on two lines. So we substituted a coordinate into both of our lines. And if it was on both of our lines, that means we have a point of intersection. Then we went through the steps of solving our simultaneous equations graphically. We sketched our two equations accurately on a Cartesian plane. So we made sure that we drew it in an accurate way, and we can use whatever method that we've learned over this course of the topic to do that. Then we found the point of intersection on our Cartesian plane. So here we read off 2, 2, and then we just write as a final step, x is equal to 2, y is equal to 2. This final step that I did here of checking was just to show you that this does work out for both of my lines. This doesn't need to be done unless the question asks you to. So that's it for today's lesson, Year 9s. Hopefully that was helpful for you guys. And if you have any questions, feel free to send a comment in our Google Classroom or email me directly, or just watch back on some of the sections in this video again slowly and go through a question alongside it. But that's it. I hope you guys are staying safe wherever you are. And that's it for today's lesson. I will see you guys in the next one. Bye.